Part D of this experiment, use of extraction to isolate a neutral compound from a mixture containing an acid or base impurity. So in this part of this experiment, you would be given a sample which contains a known neutral compound and an acid impurity. So that's the sample. It has the unknown code, number 1. It has a neutral compound and it has the acid impurity associated with that. So our objective is to remove the acid impurity. And then when we have the pure neutral compound, we need to determine its identity by testing its melting point. And the list of the neutral compound is mentioned here on page 34 of your lab manual. Fluorinone, fluorine, 1245 tetra, chlorobenzene, or triphenyl methanol. So it could be any one of it. So this is basically a process, a flow chart, how you are going to remove the acid impurity from the neutral compound. So first of all, you are going to dissolve this mixture, having the neutral compound and acid impurity, which I just shown you. It's in this test tube, right? You are going to dissolve this into ether. And then you will add this solution into separatory funnel. To the separatory funnel, you're going to add the NaOH solution. And then you would basically partition it. And once you partition it, you would have an ether layer and an aqueous layer. Aqueous layer will be the lower layer and ether layer will be the upper layer because ether is less dense. So in the aqueous layer, acid will convert into a salt, right? Sodium salt, because you are using NaOH, right? So this will be an acid-base reaction and you would get a salt. So this is an ionic compound. So that's how acid will be dissolved in the aqueous layer. Here is the ether layer. Ether layer will contain your neutral compound. Then to the ether layer, you would add the saturated aqueous NaCl. The purpose of adding this saturated aqueous NaCl, this is also called as brine solution, so that you would remove the water molecules which are present in this ether layer. Because at the end we need to just isolate our neutral compound. We do not need any water in it, right? So our purpose is to remove all the water from it. So that's what we are going to partition it with the saturated aqueous NaCl solution. And then we would have again here 2 layers, ether layer and the aqueous layer. This aqueous layer, we can discard it because we do not have anything in it. It's just some water molecules will be there. And then we have here ether layer. To this ether layer, we will add solid sodium sulfate. It is a drying agent, right? And then you would get then dried ether layer. This dried ether layer, you're going to evaporate it. Once you evaporate ether, you would get your solid neutral compound. And then you would record the mass of it and check the melting point to figure out its identity. Let's come this here now. So we already talked about in this aqueous layer, you would have salt of NaOH or sodium salt basically. To this layer, you're gonna basically isolate this layer from the separatory funnel into a conical flask, and then you're gonna add the 6 molar HCl. Once you add the 6 molar HCl, you're gonna precipitate the acid out of it. You did actually similar reaction in the experiment number 1, solubility. So what is happening here? This is salt, right? Once we add acid to it at this point, once we add acid, this is H plus Cl negative. So basically, again, this is negative part. It will attach with the proton, and left is the NaCl. So you will get plus NaCl, and that's how you would get the precipitate of acid. In your lab manual as well, there is a flow chart is given in order to remove the acid and base impurities from the neutral compound. So this chart tells that if you have both acid and base impurity associated with your neutral compound or added to your neutral compound. So procedure is same. You're gonna add the ether, and then once you will add NaOH, it will remove the acid impurity, right? So the ether layer will then have your neutral compound and the base. But then base is still an impurity. You need to remove it. In order to remove the base, you need to add acid so that it will form a salt. Acid-base reaction will happen and it will form a salt, which is this one. And then this will be present in the aqueous layer, right? So this will come into aqueous layer in the form of a salt, right? That's the acid part and that's the base part. So again, you would get your ether layer will have only the neutral compound, and then you're going to proceed further with washing with brine, drying with sodium sulfate, taking the melting point, and everything at this point. I transferred the 0.36 grams of mixture of the neutral compound and the acid impurity into the screw crab centrifuge tube, and then I'm going to add 10 milliliter of ether into it to dissolve it. I've already added 10 milliliters of ether to that mixture, and I'm going to now dissolve it. So this is the centrifuge tube containing 10 milliliters of ether and the solid mixture. Now it's completely dissolved. I'm going to add this solution into the separatory funnel now. I'm going to add now 1 molar NaOH. It is 5 milliliter of 1 molar NaOH. I'm going to add to it. Now I will shake the separatory funnel for 30 seconds, the same way as you have seen in part A, so that the acid impurity will come into the aqueous layer. And then I'm going to separate both the layer. So the lower layer will come into this under my flask labeled first NaOH extract. Actually separating out the layers, shaking the funnel for the extraction. Now the layers are separated. I shook the funnel for 30 seconds and I let it sit for some time, and then now you can see the layers are completely separated. Now I'm going to remove the lower layer into this under my flask labeled first NaOH extract. This is the second time I'm going to add 1 molar NaOH, 5 milliliter. And I'm going to follow the same procedure, 30 seconds shaking and letting it sit for some time, separating out the lower layer. This time I'm going to separate out this lower layer into the second under my flask labeled second NaOH extract. So I did both the extractions. This is the first NaOH extract. This is the second NaOH extract. Right, so I'm going to add now 6 molar HCl in both of them, drop-wise, and check the pH until it is acidic. Now I'm going to add the 6 molar HCl into the first NaOH extract. You can see the precipitate as it starts forming. Let me check what is the pH. Is it acidic or not? No, I can add more. Now you can see that this pH is pretty acidic, close to, between 1 and 2. Right? So now you need to figure out what is this precipitate. right? I already mentioned when I was talking about the flow chart, the process of separation of the acidic impurity. So from that, you would get a hint that what is this. The same process I'm repeating here with the second NaOH extract, addition of HCl, stirring. Let me check the pH. So still more can be added. Yeah, so it's pretty acidic, as you can see, right? So now, do you see any substantial amount of precipitate in it? Right, very less amount of precipitate in the second extract. Very less amount of precipitate is there. Right, so what you can conclude based on these two results, like this is the first NaOH extract, right, and then and this is the second one. So the amount of precipitate in the second one is very little. So it shows that almost all of the acid impurity is now in the aqueous layer, right? Because you need to figure out what is this precipitate. If you're not getting precipitate, that means you are actually pretty much separated or extracted all of your acid impurity into the aqueous layer. Now, if you would get, let's say, a heavy precipitate into the second NaOH extract as well, then you have to go for the third extraction until you will get, like something like this. So based on that, we can say that 2 extracts are good enough. Now the separatory funnel contains only ether layer. I'm going to add 5 milliliter of saturated sodium chloride solution, and this is also called as brine solution. The purpose of this solution is to remove the remaining water from the ether layer. So I'm again going to shake the funnel, let it sit, separate out the lower layer, and this time the lower layer I'm going to discard it. So this is the lower aqueous layer containing brine solution, and that's the ether layer. So this layer I'm going to discard it. So now this has the ether layer, right, the upper layer. So I'm going to remove the upper layer from the top of the separatory funnel, not from the bottom, because if I'll remove from the bottom, I have already removed NaCl's brine layer from the bottom, right? So it's not good to remove the upper layer from the bottom because it has some water molecules in this portion, so it's good to remove from the top. So this is my ether layer, right? I'm going to dry completely it with the anhydrous sodium sulfate, the way you saw in part A and part B. Little bit sodium sulfate to it. As you can see, it's free flowing, so I don't have to add more. Now I'll let it sit for 10 to 15 minutes and then I'll proceed further. This is the mass of the conical flask. It's already now 15 minutes, so I'm going to transfer this dried ether layer into the pre-weighed Erlenmeyer flask, and then I will evaporate that ether to get the compound. So I'm evaporating the ether layer, the dried ether layer, into the warm water bath. So make sure the temperature of the water bath is not too high. Make sure you perform this step of evaporation of ether in hot, because ether is a toxic compound. The ether is evaporated, and now these are the crystals of the compound, the neutral compound. I've dried the flask from outside, so no water droplets are outside. Now I let it sit for a couple of minutes so that it will come to the room temperature. It's a little warm right now. And then when it comes to the room temperature, then I will check the mass and will record the melting point. So this is the mass of the conical flask and the compound. You need to subtract the mass of the empty flask from this mass in order to get the mass of the compound. So basically I prepared the sample like I mentioned already in part A. I'm going to place my sample here in the aluminum heating block, and then I'm starting with the lowest melting point in the range, so which is started from 80 to 85. So you can see the sample is right there, and I'm waiting and then check that what should be the identity of unknown based on the melting point. So I would say that sample is just started melting. And it's almost done. And I would say it's completely melted now. So you can see the sample in the completely melted. So you need to figure out your unknown based on this chart and the melting point. So you are going to dispose of this waste which I've used to prepare the melting point tube into the solid organic waste, and this one you are going to put it in the recovered bottle. So you will find a recovered bottle and you're gonna put it there. And basically this is a capillary tube. The melting point tube is used one. It will go to the glass trash. So these three aqueous extracts I'm going to dispose of in the aqueous waste. It's all in this experiment number 3 extraction. Thank you.